Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions from October-November 2021 paper 1. In today's lesson, our main focus will be on waves and electricity. As always we will discuss these questions in detail so you can improve your conceptual understanding of these topics and also you can have better understanding of these questions. Let's study together, let's improve together. Question 26 says a smooth surface has bumps on the surface that are smaller than the wavelength of visible light. What is the approximate maximum size of the largest bumps on the surface? So for this question, first of all, we need to understand what is the wavelength of visible light. Lambda for visible light. Lambda for visible light is from 380 nanometers to 740 nanometers. So simply you need to remember this range. Now we need to find out the maximum size of the largest bumps. So if you look at 20, this one is too small, so we can ignore that. Next one, this is 350 nanometers and this is very close to 380. So this can be the maximum possible size. And this is 720. This is in this range. It has to be smaller than the wavelength of visible light. So it means this is also not possible. 5.0 times 10 to minus 6. So we can convert this one into nanometers. So we can multiply with 10 to 3 and also we can multiply with 10 to minus 3. So if we little bit rearrange this one, we can write down 5.0 times 10 to 3 multiply by 10 to minus 6 multiply by 10 to minus 3. So it means that we have 5000 nanometers. 5000 nanometers. So 5 micrometer is equal to 5000 nanometers. And this is greater than the wavelength of visible light. But we have to find out smaller than the wavelength of visible light. So the best answer for this question is 350 and this is the maximum size. So this has to be close to the smallest wavelength of visible light. So the answer for this question is B. Question 27 says two progressive waves travel in opposite directions and form a stationary wave. The graph shows the variation with distance x of the displacement of the stationary wave and of one of the two progressive waves at the same instant in time. What are the approximate displacements of the other progressive wave at the positions j, k and l? So in this case, this is over one progressive wave. So this is one progressive wave. So this is one progressive wave and this is the stationary wave. So this one is stationary wave. And the displacement of the stationary wave, this is the resultant displacement, or simply we can say this is the net displacement. And net displacement has to be equal to the displacement of one progressive wave plus the displacement of second progressive wave. So if you look at point J, we have displacement of one progressive wave that is equal to 0. And we have displacement of stationary wave, means we have the net displacement that is equal to minus 5. So from here we can write down the d2, this is equal to minus 5 centimeters, minus 5 millimeters, because the unit of displacement is millimeters. So we can write down this is minus 5 millimeters. So this is minus 5 millimeters at point J. So answer can be A or answer can be B. Now if you look at point K, at this point we can write down d net here, d net. This has to be equal to d1 plus d2. So at this point we have d1 and we can also write down d2. We have value of d1 that is equal to plus 5. So we have plus 5 here and net displacement at this point that is also equal to 5. So it means that d2 has to be equal to 0. So it means this one B is not possible because this one has to be 0. And now if you look at the last one, we can also write down d net again. This has to be equal to d1 plus d2. So if you look at point L here, the net displacement, this is equal to 0, and d1, this is equal to 10. So we can say this is 10 plus d2. So d2 from here, this has to be equal to minus 10 millimeters, minus 10. So the answer for this question is A. So the main concept is this one: the displacement of stationary wave is equal to the vector sum of displacements of individual progressive waves. So the vector sum. So we can say this has to be the vector sum. So the answer for this question is A. Question 28 says, which diagram shows the diffraction of water waves in a ripple tank? For diffraction, we need to understand when the wavelength of the waves is approximately equal to the gap size. In this case, we will observe significant diffraction. So we will observe significant diffraction, significant bending of waves after passing through the gap. Now if you look at this figure, we can say this is A, let's say this is B, this is C. So we need to understand, if we increase the gap size and if we keep lambda same, how diffraction is changing. So in this case, lambda is greater than gap size, so we have lambda greater than gap size, so we have a lot of diffraction, a lot of bending, is almost circular. Now if you look at the second one, in this case lambda is about equal to gap size, about, so we observe this much diffraction, we observe this much diffraction. And now if we increase gap size, means the lambda is smaller than gap now, so we see very little diffraction. So we have to keep this one in our mind. If we have this one in our mind, now we can answer the question. So if you look at the first one, lambda is greater than gap size, so there has to be a lot of diffraction, but this is telling us there is no diffraction, so it means this is not possible. And if you look at this one, again lambda is greater than gap size, but this is showing very little diffraction, very little bending, so this is also not possible. In this case, lambda is greater than gap size and we see a lot of diffraction. I mean, these are almost circular. Bending is a lot of bending in this case. So this can be a possible answer. In this case, lambda is greater than gap size, and we can also compare this with this given figure, mean with this figure. So that this can be a possible answer. This one is incorrect. This is telling us waves are coming from here. The source is located somewhere here. Actually, the source is here, so this one is incorrect. So the answer for this question is C. So you have to keep this figure in your mind. How amount of diffraction changes with the gap size. So if we keep on increasing gap size and we keep lambda constant, diffraction decreases, and vice versa is also true. So the answer for this question is C. Every year you will see one question about diffraction and about these figures, so you have to be very clear about diffraction and how we determine diffraction is significant or not. So this is the angle of diffraction. So this is, if we draw the line from here, and this is angle of diffraction, so this angle is important. If this angle increase, it means diffraction is increasing. So this is angle of diffraction. We can also draw a line here, so we can see how much diffraction is there. So this is angle of diffraction, this is. So we can compare, if this angle is increasing, it means diffraction is increasing. If this angle is decreasing, it means diffraction is decreasing. Question 29 says, interference fringes are produced on a screen by double slit interference using light of wavelength 600 nanometers. The fringe separation is 4.0 millimeters and separation of the slits is 0.60 millimeters. What is the distance between the double slit and the screen? Pretty straightforward question, so we can simply sketch here. So this one is over double slit and this one is the screen. For this question, we have the slit separation. So we can say this slit separation is D, and D is equal to 0.60 millimeters, so mm. we will have center maxima at the center, then we will have first order bright fringe, then we will have second order, and so on. So first order, and here we will have second order. And for this question, fringe separation is given. We have the separation between fringes, and this separation is, we can say, is x, and x is equal to 4.0 millimeters. And the wavelength of light, we have lambda, that is equal to 600 nanometers. For this question, we need to find out value of capital D. So this D we have to find out. We need to understand dx for double slit is equal to lambda times capital D. So we can say capital D, this has to be equal to D times x divided by lambda. So we have value of D, that is equal to 0.60 millimeters. So 0.60 times 10 to minus 3, we need to convert into meters, and x is equal to 4 millimeters. So this is 4.0 times 10 to minus 3 divided by wavelength, that is 600 nanometers. So 600 times 10 to minus 9. Now if we simplify this one, we will get value of capital D, that is equal to 4.0 meters. So the answer for this question is D. So the answer for this one is D. So this is how you can answer this question. Pretty straightforward question. Simply you need to understand this D you can also replace with A. So maybe you little bit get confused with that. So we can say D we can replace with small a. So then we can say AX, this has to be equal to lambda times capital D. So this is equation for double slit. Question 30 says a ray of green light is incident normally on a diffraction grating. Several bright spots are produced on a screen on the other side of the grating as shown in the figure. Which pair of changes could result in bright spots at exactly the same angles? Exactly the same angles, not exactly the same positions. So very important one as previously. We are talking about diffraction grating. For diffraction grating, we need to understand d sine of theta. This is equal to n times lambda. So this one is over center maxima, so n for this one is equal to 0, and this is over first order maxima, so n for this one is equal to 1. From here we can write down sine of theta. This one has to be equal to n lambda divided by d. So we can say theta has to be equal to sine inverse of n lambda divided by d. In this case we need to compare, so we will be comparing first order with first order and second order with second order. So for the first order we can say n is equal to 1. So we can say theta in this case will be equal to sine inverse lambda over d. We are comparing first order. So n is equal to 1. For the second order, n will be equal to 2, or simply we can say n is constant. So we will be comparing first order with first order, second order with second order, and so on. So for this question, if we increase the lambda, we want to keep theta same, so we also need to increase the d, and vice versa is also true. If we decrease lambda, we have to decrease d as well. So this is the main concept we need to understand. Now if you look at given options, it is given to us use blue light. So for visible light we need to understand rho g if. So if we use blue light, lambda decreases. So in this case lambda decreases. Lambda decreases, it means that theta also decreases. Theta also will decrease. And it is also given to us increase the distance between the grating and the screen. So this is telling us we move the screen little bit away. So we can place the screen here now. We place screen at this point. If we place the screen at this point, there will be no change in angle. So if it is here, so the same line, the position of the bright spot will change, but there will be no change in angle. So very important point we need to understand. By changing the position of the screen, angle will not change, but position of bright spot will change, or we can say distance between bright spots will increase. So in this case, angle will not change. So due to this one, angle will not change, but due to blue light, because lambda is shorter, so this theta will go down. So this is not possible answer. Now if you look at second option, it is given to us: use blue light and increase the number of lines per unit length in the grating. So if we increase the number of lines per unit length, means d is equal to 1 over n. If we increase this one, this will also go down. So for the second option, it is given to us: we decrease wavelength and also we decrease d. So it means theta will remain same. So this is our possible answer for this question. Now if you look at option C, use red light, means you increase the lambda and increase the distance. Increasing distance will not affect anything, will not affect the angle, just will affect the position of bright spots. So if we increase lambda, it means theta will increase, so this is not possible. C, use red light, so it means theta will increase. Increase the number of lines, so it means d will decrease. If d decrease, theta will also increase, so theta will not remain same. So this is also not possible. So the answer for this question is B. A beautiful question. Next time they can ask you how position will change. So you need to understand, if we move the screen away, position means the distance between bright fringes, that will increase. Then if we move the screen closer to the diffraction grating, fringes, they will get closer, angle will stay the same. Question 31 says two parallel metal plates are at electric potential of 800 volts and 1300 volts. Which diagram best represents the electric field between the metal plates? So first thing we need to understand, parallel plates, electric field between parallel plates is uniform electric field. Uniform electric field. If the field is uniform, so the lines should be equally spaced. Lines should be evenly spaced, or we can say equally spaced. The space between lines need to be the same, and line has to start from high potential to low potential. So if you look at this one, this is a high potential to low potential, but the problem is that the edge effect is not correct. So this has to be curved upwards, so it has to be like this. So that's the reason this is incorrect. The line start from high potential to low potential, yes, so this is correct. The space is evenly, so this space is even, so this is correct. Edge effect, this is also correct, so the answer can be B. And if you look at this one, line has to start from high potential to low potential, so that's the reason this one is incorrect. Direction is incorrect. And if you look at this one, high potential to low, this direction is incorrect, so this is also not answered. But this question is not part of new syllabus, and this is from old syllabus, and I hope this question is clear to you. Question 32 says an electron is in a uniform electric field of field strength 1500 volts per meter. What is the acceleration of the electron due to the electric field? So for this question we need to calculate acceleration, and acceleration has to be equal to F net over m. So this is the first thing we need to understand. And when the electron is in the electric field, the net force on electron is the electric force, so we can say F. So this is electric force, F divided by m. And electric force, simply we can calculate F is equal to E cube divided by m. And E is given to us, so we have value of E. This is already given to us, so this is 1500 volts per meter. And value of Q is the charge on electron. Charge on electron is 1.6 times 10 to minus 19 coulombs, and the mass of electron is equal to 9.11 times 10 to minus 31 kgs. Now simply we need to plug in values and we can find out value of A. We have value of E, that is equal to 1500 volts per meter. We have value of Q, that is equal to 1.6 times 10 to minus 19 coulombs divided by the mass of electron, that is 9.11 times 10 to minus 31 kgs. So if we solve this one, we will get 2.6 times 10 to 14 meters per second per second. Very, very high acceleration. So the answer for this question is D. And this question is also from old syllabus. Question says a lightning strike transfers 1 times 10 to 20 electrons past a point in a time of 30 microseconds. What is the average current during the lightning strike? Average current. So we need to understand what is average current. Average current is equal to the total amount of charge passing through a point divided by the time taken. So we can say divided by delta t. So in this case, the total charge passing through a point is 10 to 20 electrons we have, and the charge on single electron is 1.6 times 10 to minus 19 coulomb. So this is the total charge passing through a point in time of 30 microseconds. 30 times 10 to minus 6. Now if we solve this one, we will get 500 times 10 to 3 amps. So simply we can say this is equal to 500 kilo amps. A very high current. Very high current. So this is how we can calculate. So current is the amount of charge passing through a point per unit time. So in this case we are taking total charge passing through a point in given time. So this is how we can calculate value of I. Question 34 says a cell has an electromotive force of 6 volts and internal resistance capital R. An external resistor also of resistance capital R is connected across the cell as shown in the figure. Power P is dissipated by the external resistor. The cell is replaced by a different cell that has an EMF of 6 volts and negligible internal resistance. What is the new power that is dissipated in the external resistor? For this setup, it is given to us power dissipated is equal to P. And in this case, the voltage across this resistor, the V across this resistor, this one has to be equal to 3 volts. Because we have two identical resistors connected in series, so we can simply use V square divided by R, and in this case value of V we have that is equal to 3, and this is divided by capital R. So we can say 9 divided by R, this is equal to P. So simply we can write down here. For the second case, we can resketch. We have cell that has no internal resistance. So this is our new setup. EMF of this cell is 6 volts. So the PD across this resistor also has to be equal to 6 volts, and resistance of this resistor is capital R. So we can write down the power dissipated, that will be equal to 6 square divided by R. So here we will get 36 divided by R. So we can say this is P nu. So this is value of P nu. We can simplify this one. We can say this is 9 divided by capital R multiplied by 4, and 9 by R, this is equal to P. So this is multiplied by 4, so we can say this is equal to 4P. So in this case, power dissipated in this resistor is 4 times of the initial value. So this is equal to 4P. So the answer for this question is D. Question 35 says a wire of uniform cross section has resistance capital R. A second wire is made of the same material but is twice as long and has twice the diameter of the first wire. What is the resistance of the second wire? For the first wire, we can simply say R is equal to rho capital L divided by A. So this is for the first wire. So we can say this is R1. For the second wire, we can also write down R2. This is equal to rho. They are made of the same material, and this is equal to 2L. Length is double and twice the diameter. Diameter is also double. So we can simply write down A nu. If the diameter is double, so A nu has to be equal to pi by 4 d squared. So the diameter is double. So the cross-sectional area will be equal to pi by 4. We will have 4 times d t square, mean this will be equal to 4 times of a. So we can say this is 4 times a. Now if we simplify, we can cancel this 2 here with 2. So we will get rho L divided by a and multiply by 1 by 2. And rho L by a, this is equal to R. This is equal to R. So it is R divided by 2. So the new value of resistance, this is half of the previous value. So the answer for this question is B. Question 36 says the diagram shows two resistor networks. What is the ratio between total resistance of network 1 and total resistance of network 2? So first of all, we have to find the total resistance. So if you look at network 1, we have two resistors, they are connected in parallel. So the total resistance of these two resistors has to be equal to 2R divided by 2. So it means this is simply equal to R. Then these two resistors are connected in series. So we can say R total of this network is equal to 2R. Now if you look at this one, again we have two resistors, they are connected in parallel. So the total resistance of these two resistors will be equal to R divided by 2 because they are connected in parallel. So R total for this network will be equal to 2R plus R by 2. So it means this is 4R plus R divided by 2. So it means this is 5 by 2R. So we need to find the ratio now. So first network 2R divided by 5 by 2R. So in this case we will get 4R divided by 5R. So simply this is equal to 4 by 5 because R will be cancelled. So this R will be cancelled. So the answer for this one has to be 4 by 5. So the answer is A. Question 37 says the circuit shown contains 3 cells of electromotive forces 3.0 volts, 2.0 volts and 4.0 volts in series with a resistor of resistance 5.0 ohms. The cells have negligible internal resistance. What is the current I in the circuit? So we need to calculate value of I in the circuit. So we can start from here and we can redraw the circuit. So we have negative terminal, then we have the positive terminal, then this cell is 3.0 volts. After this one we have the resistor, so we can redraw this resistor. So this is 5.0 ohm resistor. And after that we have this cell, so we have the negative terminal, here we have the positive terminal, and this cell is 2.0 volts. After that we have positive terminal of this cell, so we can draw this is positive terminal, and here we have negative terminal, and then simply we can draw this line. So this is our circuit now. So it just a wire between these two terminals, and this is 4.0 volts. We need to find out current in the circuit, mean value of I in the circuit we can draw here. So this is current in the circuit, so as they are connected in series, so current in the circuit is the same. So how we can find current in the circuit? Current in the circuit I, so we can say this is I, this has to be equal to net EMF in the circuit divided by the total resistance of the circuit. So this is the main idea. We have total resistance in the circuit that is equal to 5.0 ohms. So what is the net EMF? If you look at these two cells, they are connected in series. So we have 3 plus 2 means 5 volts, but this is connected in the reverse order. So it means 5 minus 4. So the net EMF will be equal to 1.0 volts. And if we solve this one, we will get 0.20 amps. So the answer will be A. So this is how you need to approach. So you need to find out what is net EMF, and then we can figure out current. So these two cells, they are connected in series, but this is connected in reverse order. So we have to subtract this one. So we can also say this is positive, this is negative. So if you add, you will get 1.0. So the answer for this question is A. Question 38 says, when alpha particles are fired at a thin metal foil, most of the particles pass straight through, but a few are deflected by a large angle. Which change would increase the proportion of alpha particles deflected by a large angle? So we need to increase the diffraction. So it means that we need to increase large angle. So we need to increase deflection. In order to increase deflection, we need to increase the repulsive force between alpha particles and the nucleus. So we can say repulsive force we need to increase. So how we can increase the repulsive force? So if we have more nuclei in the way of alpha particle, so we can increase the repulsive force. So more nuclei in the way of alpha particle. So how we can increase more nuclei? It simply means that we have to use thick metal foil. So that's the point you need to understand. Thick metal foil. Alpha particles with greater kinetic energy, this will decrease the diffraction. So this is not possible. Use a double thickness foil. Yes, increase the thickness. So this can be possible. Using a foil made of metal with fewer protons, this will also decrease diffraction. Using a source emitting more alpha particles per unit time, this will not affect deflection. So this is the answer. So the answer for this question is B. Question 39 says, a nucleus of neptunium 236 contains 93 protons and 143 neutrons. This nucleus decays with the emission of an alpha particle. The nucleus formed then emits a beta minus particle. Which diagram shows the changes in the number p of protons and number n of neutrons in these nuclei? So for this question, first of all, we need to understand alpha particle. It consists of 2 protons and 2 neutrons. And in any alpha decay, let's say we have nucleus X and here we have nucleus Y, and this is alpha decay. So it means alpha particle will be emitted. So let's say mass number is A. So the atomic number of this nucleus has to be Z minus 2 and the mass number has to be A minus 4. So it simply means that proton number decreases by 2, so this is minus 2, and the neutron number also decreases by 2, so this is minus 2. Now we need to understand beta minus decay. So we can say beta minus decay. For beta minus decay, we can also assume nucleus X, let's say this decay to nucleus Y by emitting beta minus particle, mean fast moving electron. And also here will be electron anti-neutrino. So in this case, if the atomic number of this one is Z, mass number is A, so the atomic number of this one will be Z plus 1 and mass number does not change. So it simply means that in this case proton number will increase by 1, and as mass number does not change but proton number increases by 1, it means the neutron number will decrease by 1. So that's all what we need to understand. So this is one point you need to understand, and this is the second one. So these are the points we need to understand. Now if you look at given options, this is telling us neutron number decreases by, here we have 143 and 1/3, decreases by 4, so this is incorrect. And if you look at this one, this is telling us neutron number decreases by 2, and then it is, and proton number also decreases by 2, so this is 93, 91, so this is right. This part is right. This is telling us neutron number increases by 1 and proton number decreases by 1, so this is incorrect. And if you look at this one, this is telling us neutron number first increases by 2 and proton number also increases by 2. This is incorrect because neutron proton number decrease. And if you look at this one, this is telling us neutron number decreases by 2, so we have minus 2, and proton number also go back, so this is decreases by 2, so this part is correct. and this is telling us neutron number decreased by 1 and proton number increased by 1. So this is also correct. You can also complete this diagram, this triangle, for example, here. So this is -2, this is also -2, and this one you can draw this small triangle. So this is -1 and this is +1. It means this is the right answer. Question 40 says, which combination of quarks could not be the quark composition of the hadron shown below? P for proton and for neutron. So these are two hadrons, sigma minus, sigma plus, and up quark we have here. So the charge on up quark we need to understand is -2/3e. This is +2/3e. And charge on the down quark, this is -1/3e. And charge on the strange quark also is -1/3e. Now if you look at given hadron, first of all we have sigma minus. Charge on this one is -e. So we can try to figure out. So we have two down quarks, so we have 2 times -1/3e, plus we have strange quark -1/3e. So if we add them together, we will get this is -e. So it means this composition is possible. Now we can check sigma plus. We have one up quark, down quark, and strange quark. For up quark we have +2/3e, and then we have down quark, so this is -1/3e. Simply you need to add charges together, and strange quark -1/3e. So if we add them together, we will get 2/3e minus 2/3e. So it means this is equal to 0. That it is given to us, it has +1e charge. So it means this composition is not possible. We need to find out which composition is not possible. So it means answer for this question is B. If you look at next one, proton, yes, this is standard composition. So this is possible. This is also possible. So the answer for this question is B. So we have discussed all the questions from this paper. And if this video was helpful, please like and subscribe, because your encouragement is very important. And also, if you need more help, you can join Patreon. On Patreon you can connect with me more directly, and also on Patreon a lot of resources are available. And also, if you have any questions, leave your questions in comments and I will try to answer your questions as soon as possible.